Hi there. In this video, we're going to find an ideal sample size when we are doing a confidence interval for a mean. Okay, so just like when we did with proportions, so we've done this before with proportions when it wants you to find an n, right? It gives you a certain margin of error. So when given a desired margin of error, so we're given an ME, we can find the sample size. And we did this for the other formula where I just showed you the result, but if you want to use algebra and reverse the formula, you can do that. So if we took this formula, just the margin of error part, so just the part after the plus or minus, margin of error is the t star sub n minus 1 degrees of freedom times s over square root n. So if you square both sides, multiply both sides by n, all that stuff, rearrange the formula using algebra, you get this version. N equals t star times s over the margin of error, all that squared, okay? Now, there is a bit of a problem with this formula that you might recognize. See the n on both sides? So the problem is we don't know what t star n minus 1 is without knowing n. Okay, so we could use an iterative process where we try something and then we just adjust this as we go, but that's more complicated than I would like it to be. So what we're going to do is actually use z star instead of t star. Okay, so we're going to go back to the z stars we know from proportions. Okay, so we could use an iterative process. So, and especially when n is greater than 60, so we've got even more than 30, we've got 60, z star is a good enough substitute. Okay, which probably, if we'll be trying to find a smaller margin of error, we'll probably have a larger sample size. Okay, so instead of this original formula, we're going to modify it just a little bit. N equals z star times s over the margin of error. Okay, so then it's similar to what you're used to doing with proportions, but that one would have a p hat and q hat in it, right? So this one has s in the desired margin of error. And just a reminder over here, sample size must be a whole number, so we always round up even if the decimal is under 0.5. If we were to round down, that would just make the margin of error larger than we wanted. So always round up. Just a reminder about that. Okay, so let's try it. We have this credit hour data, so let's try it with that. So continuing the example above, calculate the sample size needed to reduce the margin of error to 0.5 credits. Okay, half a credit. Let's say we want it to be within half a credit of it for our estimate. And maybe we want it to be within 1 credit, whatever. That's going to be our input to our formula right there. Okay, and we're going to continue with the 90% confidence. Okay, so, and then another thing to remember, you might remember before we always had to enter this as a decimal. So we had to move, it would say like plus or minus 4, but we'd have to put it to 0.04. We don't want to do that now because we're not in percentage. I guess there's a slim chance it could be percentage, so you have to look at the context. It's usually not a percentage, so we won't move the decimal place. Okay. I do have the note here. If the numerical data are proportions, we might need to move the decimal place. So you can have a numerical data set that is all in percentage or proportion. Okay, so let's practice using this formula. N equals, okay, z star, we have to remember that z star is 1.6449 for 90%. We've got that on our formula sheet. So I will use that. N equals 1.6449. Then I'm going to multiply these all times s, and I just happen to have our GeoGebra thing here on this page that was 3.4682. Over the margin of error, so this is half a credit, and the whole thing squared, okay? So we've got a multiplication and a division all inside the square. Okay, I'm going to go over to Desmos calculator for this one and put in the 1.6449 times 3.4682. Now, if I just hit divide, it's only going to divide the second one. That is technically mathematically going to be correct, but just to make it look the same, I'm going to end a parenthesis, and then actually should have started with parentheses 0.5 because I want to square this whole thing. Okay, so learn from my mistake. Start with parentheses. I can add them, fortunately, just with the mouse before. But if you start with parentheses and then do a double set for the top and then the bottom. And then I'm going to do caret square, or you can use the square button down here. So I'm getting 130 people, 131 people, because it's 0.18. We're going to round up. So let me write that down. So I'll write the original number first, 130.18. Then we want to round that up to 131 students. Remember, the units for n are now going to be whoever our cases are, right? Our subjects. So now we need to sample, we need to survey 131 students to have a margin of error of 0.5 credits. Okay, so also a little different just because the margin of error has units other than, sometimes, most of the time, other than a percent. Okay, let me just make sure that's visible. Okay, great. I hope it's making sense. I will see you in the next video.